this video, we're going to determine where an algebraic function is continuous. It says, state the intervals over which the function f of x equals root 3x squared minus 9x is continuous. Well, we know that a square root function cannot have, you cannot have the square root of a negative inside the function. So 3x squared minus 9x is going to have to produce something that's 0 or larger. So that's how I'm going to find where the domain is restricted. Is I'm going to say that 3x squared minus 9x has to be greater than or equal to 0. And then I'm going to solve this by saying x, we're going to factor out a 3x, that's x minus 3 has to be greater than or equal to 0. Now at this point I'm going to use ZPP, so I'm going to say that 3x is going to equal 0, or x minus 3 is going to equal 0. Now this is a quadratic inequality, so once I figure out x equal 0 when I divide by 3, or x equal 3 when I add the 3 over, I draw a number line. I mark a 0 and 3, and I figure out where are the solutions, where are the okay areas, I guess I should say, for the domain to be. So I'm going to plug in like -1, 0, and 1 into the function and just see where that works out. So if I plug in -1, I'd have 3 times -1, -1 minus 3. That'd be a negative times a negative, which would be positive. So this area here works. So I'm going to kind of put a circle there, check mark, we're good. If I plug in 0, I get 0 times 0. Oh, I can't plug in 0. 0 is part of my domain, or part of my, 0 is one of my zeros. So I'm not going to plug in 0 and 1. I'm going to plug a 1 in there and a 4 in here. So I plug in 1. I get 3 times 1. 1 minus 3. That's a positive 3 times a negative 2. So that would be a negative. So it has to be greater than or equal to 0. This area does not work. And then I plug in 4, and I get 3 times 4, and 4 minus 3. Well, if I multiply those together, I end up with 12 greater than or equal to 0. That is true. So this area works. So this function is continuous from negative infinity to 0, union 3 to infinity.